Hello, hello, my friends. Hello and welcome. Welcome to my stream. Long time no see. Long time no see, meine Freundin. I hope that there are a lot of updates. I hope you didn't miss me too much. From the last time, we have several follows. Let's say their names out loud, at least something to give them away for their liking of me. The Primagion, thank you. Crypto Lake, thank you for the follow. Helios 0x2a, thank you, Helios. And Os 00312 underscore underscore underscore. Thank you, Hos. And yeah, we have Vigil in the chat. Welcome. I remember you from the last stream. I hope you are doing well. So there are a lot of updates, and I do not really remember if I gave proper updates from the last time, which was a month ago, but luckily for you, there are not as many as there could be updates. I was ill for the last 2 weeks, so I didn't touch code very much, so I honestly even forgot a little bit how it is to code in Zig. Let me give you just a brief update of code structure, I guess. Just a general sense that we have nothing working. I even have this function main, and it says so far nothing in the main, try Zig build test. We have a lot of tests and basically a lot of files which are supposed to be, each file is a different abstraction layer, and it is made for the purpose of isolating each component so we can reuse it. For example, yeah, well, here is JSON RPC. I wrote an implementation of JSON RPC, and for our application we don't really need the whole power of JSON RPC. We have a very specific our RPC, and this is our RPC file, rpc.zig, right? And here we have RPC implementation JSON RPC, right? For now we have only a single kind, but we keep in mind that maybe we would like to use this protobufs message pack or whatever else you could imagine, right, for RPC. And we, from the start, we leave the possibility of migrating to this new hip cool thing, or maybe we have problems with existing implementation, and it is interleaved, threaded throughout all the implementation of this exact piece of code, right? Like here, not much here, like not a lot of variance here, because the code is not very complex here. And for all the files, all the files here, similar approach, totally similar approach. This is our current text buffer, and we will come back to it later. Let's keep this whole structure in code, and let's maybe... I would like to give you several updates regarding this. Okay, first of all, I had a change of heart. Currently, I am trying to migrate to Source Hut, because I believe it is a better platform in a lot of respects. Maybe not so popular as a major downside, but otherwise I think it is a very capable resource for keeping projects, hosting things with Git. Mercurial, here it is, 8G. I didn't try too much, but maybe I will, because it is here. And recently, because I couldn't really code stuff, I did a lot of documentation things. For example, previously there was like a huge page of README, and now it's very, very short. If, by the way, yeah, if you would like to build for some reason, you would like to build, there are instructions to do it. And there are several resources for communication. For now, I think we will try to do a patch mailing list approach instead of GitHub pull requests. For example, here you can read about contributing. But for communication, I made a Discord server, and for new Zoomers, for people like me. And I will try to use the email approach for all the other things like announcement, discussions, and my personal email. If you would like to write me something, I don't mind. At this point, while I have 0 emails per day, I'm quite okay if you're going to write me and ask any questions or just say hello. Okay, and now about documentation, right? I was talking that I spend a lot of time on it. So first of all, this is a roadmap. This is very raw. I didn't do any styles. If you use some kind of a text web-based like Emacs EWW, I think it will be a lot better. But now it is in this state, and it's basically a large to-do list. I divided our project into several stages. Here is first stage, which was done even before I started the document, and there is second stage. We are currently here, basic working program. So we are trying just to fit all the things we need, like several design documents, in order to keep in mind considerations. One of the goals, yeah, I have goals, very extensive, and one of the goals is, where is it? Yeah, make it infinitely extensible by design, no hard assumptions. And what it means is that we don't want to have any hard blocks. We don't want any hard blocks, so we the most features which are not implementable are those features which were not accounted for in the design and got hard blocked by the design decisions early in the project. This is why I would like to do all this design documentation and to feed quite a lot of things actually in the first working product, like minimum valuable product, MVP, and there are a lot of things for MVP. And this is partially because I would like to keep all the things, all the things here. I would like to implement them at least partially, at least have an infrastructure for them, like not infrastructure, like structure. At least to have structure for them, so we have some ways to extend it. And there are a lot, but at the same time we will still have to implement it later on. So today we will try to do our text buffer. It is here, 2.6 text buffer, and we will do a prototype. I also think that main implementation will be moved to the next stage. I'm still thinking about it, but for now we will do some very basic things. Our text buffer will be just a contiguous array, like the most simplest buffer possible, and we will do like very general things. There is like a bit more hard functionality, how to do folding when, for example, you do like you have a block of code and you do folding, so your beginning and end, they collapse together and it's like one line, but this one line visually is actually packs like 50 lines, 100 lines, these cases. So it's a bit harder to implement, but at the same time I think we should implement it at the very beginning so we better understand the requirements. Also because it is feature that will be generalized further on. Let me take off my sweater. It's very hot in here. Not like hot, I live on the first floor, and for all the Europeans it is ground floor, like the floor when you enter your building. This is first floor here in Pavlodar, Kazakhstan, but some countries call it ground floor. And it's pretty cool here compared to the outside, but outside it is like 35 degrees of Celsius. Fahrenheit, I don't know, sorry for all the Americans with their metric system. Okay, and let's also talk a bit about later stages. I think that second stage is pretty complete in terms of to-do tasks, and third stage, I think we will try to make a polished working program, which means that we will try to settle with all the core components, and as soon as we have all the core components, we will be ready to do extensions, which is naturally the next step, extensions, stage 4. And after that, we will implement several extensions, probably not language server protocol like in full, but like experimental extensions, right? It says so in the title. And after that, we will have a better idea of what we really need, what we don't need. And in the stage 5, we'll try to decide on the features, which features should be here. Maybe we should remove something from the core, which is unlikely because we don't try to be minimal. But still, I don't think that this stage should forbid doing anything to the core of the program. And after that, we will give it some time. We will try to use it. And sixth stage, final release, after we are content with what we have, we will put a version 1.0 and ship it. No money, of course, it will be free and open source. Okay, so I think I have spoken about most of the things I wanted to. Yeah, I think yes. Maybe I should have done some kind of a document to keep along with my update stuff. Okay, let's go to the code. So let me remember what we have here. All right, yeah, I think I remember it pretty vividly. This is our text buffer array. It is an implementation of a text buffer. And here in the state.zig, yep, text buffer. Here is our text buffer, and this is text buffer for the export. Oh, by the way, let's make it private function. Or maybe not. Yeah, maybe let's make it private. So this is our text buffer, which is going to be exported, but the way we create it is with a function, which is a macro-like, and we have text buffer implementation, right? And text buffer implementation is actually this file we were looking at. This is where we will do the work today. And here we just do several assertions. Here is our interface. We tell that this implementation should have these types. I mean, these functions. And for now, it indeed has it. Init contents with file, init contents with text, the init context, the text features and metrics. Here only metrics are missing because I still don't know how to do this naming correctly. The hardest programming problem. And the rest of it is just managing resources, right? Here is window ID, display window ID, remove display window ID, init, deinit, and all this stuff. So the idea is that this is all the behavior is about initialization and deinitialization, and also a container for all the state, like all the state things which are here. And the actual implementation behavior is going to be defined in this file. Right, so let me check that we have everything fine. So we say that above implementation, impl X functions. Here we say that yes, it should have all that. And we use here behavior, self, and here is self. Yeah, so I wanted to make sure that this self is this struct with all these data so we can reference it. So the first thing we do is, I believe we just commit this stuff. Why not? Let's go to here and make font a little bigger, right? Text, I mean, this is file state. Let's call it state. Let me fix it a little bit. Yeah. State, change function visibility. Right. Have today drink. It's called Tsikori. It's hot. I don't know if or whether anyone has Tsikori too. Let's try to translate it, because it is, I believe it is like, yeah, it is plant. Tsikorium, and in English it will be probably Tsikorium, Tsikorium. Cichorium, I think Tsikorium. Okay. Tsikorium, it's a drink like a brown powder. Very tasty. At least for me. Okay, let's keep our roadmap here and let's go to prototype. Where is it? Prototype. Here it is. So it is a text buffer prototype. I listed here some actions we would like to do. And yeah, we will need to do a lot of cursor actions. Here it is, our cursor. And let's also open our design document on cursors for this. Here it is. Maybe a little bit bigger. 132, I think fine. So here, yeah, here is it's a pretty popular paradigm to think about cursor as not just a cursor, but as a whole selection. So you don't have cursor apart from selection. Your main editing primitive is a whole selection. Here it is anchor, and here it is cursor. And this is a selection, and in the simplest case they're same, and this is like this here, this is our cursor, and at this time I use Cocoon also use same paradigm. Right now anchor and cursor are same, they are like, now they're on line 7 column 1, but if I press shift and move it, then it is a selection, right? But it was a selection, but with only difference that cursor and anchor were the same spot. And now the cursor is the white thing, this white block, and the anchor is at the letter O of const, right? So we have a selection, and this is how we will do our cursor as well. It's just easier to implement and manipulate it this way. And we will have several at the same time. We should just keep it in mind. I think mostly it will be same. We'll just iterate over each of them and do an action, like with the first. And later on we will just add some more conveniences to manipulate several cursors. Movement, yeah, here I talk about some movement, because some things are not convenient or how I want them to be, and unfortunately there is no way to change it. So yeah, here I just describe several things about how the cursor should behave. But I think we get general sense about it. Let's just write several stuff. Let's find, I believe we have somewhere cursor. No? Let's try to grab it. I use rip grab library. That cursor. So we have it in config, we have it in main. Alright. And cursor. I believe we don't have like a struct cursor. We have a struct selection. Roadmap, no, we don't have a selection. Yeah, salam bro, Jojo, welcome to the stream, welcome. We are doing some programming. Currently we will do a selection thingy for our selection. Okay, let's put it at the top, pub const selection, and it will be a struct. Yeah, and we want offset, I think. There are some situations where we would like to have like, oh, maybe I'll make it a little bit bigger. Yeah. Okay. Sorry, it all erased, but it's still working, just a bigger font. So we should have a cursor, our leading, our head, maybe use it too as an offset. I also was thinking about exact position of line column of current selection, and it could be useful, but I still don't know. Today we should really know if that is going to be useful. And we will have anchor, use it too. And we will have, probably we will have a flag primary, because we'll have several selections, several cursors, and only a single one can be a primary one. We have like a single primary one, and we will be able to switch them. The main idea that primary one is followed by the editor. For example, you have like 5 different cursors all over your big file, like 10,000 lines file, and the primary one is the one you see. If you move it down, the view will scroll down and so on. And what do we have here? Maybe some more wisdom we'll have to implement. Yeah, we will also implement this thing. Like, let me demonstrate it right now here. For example, here, currently my cursor is at the bracket, and there is also a state where I can move it to the end of line. So what will happen if I move it now down, one line down? So you see it, right? It's jumped to the comma, not to the new line. Here is new line, here is comma. So I am on new line, down on the comma. and now I am on not new line, just last character, still comma, right? And let's look at viz editor, src main.zip. Let's do same stuff. Yeah. Now I am at I'm at the angle bracket. I'm at new line now, right? This is comma, this is new line, and now I am at new line. Jump down, still new line, right? Opposite behaviors between these two editors, but we probably want to make it smarter, because sometimes I want to edit several things, like I write something here, and now I want to do same stuff on the next line. I press down, and now if I type something will be not at the end of the line, but before the last character of the line, and I need to press right. And the other way is also possible. For example, I am here, I am typing something, and if now I will be on the new line, it will be not very consistent, right? So I think we would like to have also a flag, which is going to be new line, or last character is new line, our Java style long names. But it describes what it is, right? And so we will do it like so. Like if we are on the character, we will move down to the character. If we are on the new line, we will move down to the new line. I think this is kind of what we want to do. There is just one case. For example, if we are here on the new line, if you press up, you probably want still to be here, not here on the new line. So I should think about it a little bit more. And this is why we will command this and add it to do. Think about design. Thinking, yeah. We'll do it like so for now. So this questionable feature, in some cases I find it not very convenient, but at the same time, if it is not very consistent behavior, because the last line should be like further to the right, only then it will take effect. Maybe it's not worth implementing it. Yeah, okay. Let's leave with that for now. Our selection should be ready. Let's go here and get our selection. We will just import it. Oh, right. Several things about how we import stuff. We have Kisa, a global file with all the data here, which is used. Oh, here's selection. Okay. Let's put it then here. Selection. U size or U32. Probably U32 is fine, but let's not be greedy too much. And we will change it back later. So Kisa.zig is like the main project file, and in the build, here build, we say add package path. Kisa src kisa.zig. Usually we use it for libraries like here, which are libraries which I did not write and I just want to use them. But in our case we can use Kisa like so, and at the very top we can import Kisa, just Kisa, and it will resolve, it will find the right file. Otherwise we have to specify extension and also the right path if it is not in the same directory. Yeah. So we will have Kisa.selection in our what text buffer array.zig. Kisa.selection like so. Okay, let's start. Move the cursor. Okay, we can do that, I believe. So move the cursor. Let's start by maybe let's start by understanding how exactly we would like to move the cursor, and whether we would like to actually move it or we would like to do it with an extension language. Well, yeah, let me describe it here probably. We'll use Emacs for that. And while I'm at it, let's make a font a little bit bigger so we have an easier time looking at it. In theme, here. I recently switched to JetBrains Mono, so far it looks very great. Yeah, is that visible? Or did I change only? No, I changed two at the same time. Oops. Maybe this is good on the stream. Can someone tell me? Is 150 good? Okay, I will assume it's good. Let's open our roadmap. So we go Kisa and roadmap. A little bit laggy sometimes. I would like to change it in the near future with 0 config. But we will leave it for better day. Okay, and we say we would like to have like with plus and like so, right? So we will write a list of things we would like to know how exactly to move the cursor. So we have simple ones: up, down, left, right. Exactly. Actually, with offset, it will be left, right, and then up, down. Because left, right is just moving offset plus -1, and up, down is actually calculating next line, determining current column, and going to the column of the next previous line. So it's a bit involved, right? Maybe it looks very simple, right? But when you actually dig down to the implementation, it's yeah. And we will do move to the start of the line, move to the end of line, right? Start of the line, end of the line, and maybe just one more to the first non-empty character of the line. It's often like right now it is at the beginning of the line, but let me demonstrate it here. So right now it is at the beginning of the line, but if I would like to move to the first non-empty character, it will be here on the P of the word pub. Okay, so I think it is more than enough for now. I don't plan to do a very long stream. I still don't feel quite too well after 2 weeks of being ill. So we will try to implement at least left, right. Yeah, let's do at least left, right. Okay, while we are at it, I think we should also include here something like anchored bool. So the idea is that when the editor starts, you have a selection where cursor and anchor are one and the same. And then you have some way to actually anchor your selection, and after that, cursor will be like on its own, right? And when it is anchored, cursor will be on its own. When it is not anchored, so it is false by default. False, maybe here true. when cursor is not anchored, so it means cursor and anchor are one and the same, and they move together as well. Yeah. And yeah, when I think of it, they should be usize definitely, because it is an offset. Right, let's write here, value is offset, a little bit of documentation for the next generation. All right. Anchored primary, cursor anchor. So when we first create buffer, we should actually already have a selection, right? Let's add a selection. Fan text buffer. Here we will have a selection because it is part of a state and it is state of a buffer. Is this right? Well, actually, no, it is not in the state of the buffer, as I understand. It probably should be in the display window, because we can have one buffer, but we can have several display windows looking at this buffer at the same time, and they all should have different cursors. Let's implement this little trick right now, so we don't have to deal with it later. Let's maybe do what? Here it will be easy, because like if we put it right in the text buff, it is easy, it is readily available, but we would like to put it into display window, and at this point we will also need to know about the display window, and this is where it gets a bit problematic, because we still don't know how to do it. But let's try to hack something up. So text buffer can have several display windows, and we have their IDs, and probably when we get an update like move one line down, we also have a display window ID, and we will have a way to fetch this ID, right? So probably we will have to thread our request through a text buffer and use this window ID to get our selection. Okay, let's maybe create what? Like a general function like process, and probably dispatch it somewhere. Okay, let's do our scaffolds first. So let's go to display window. It should have a selection, actually a lot of selection, but selections, and it will be std array list of Kisa.selection. It is our dynamic array here, and when we initialize, we also want to initialize our array with an allocator, which it will use to allocate new memory for new selections. Yeah, let's do what? Selection, std array list is a selection, std array list is a selection init, and we have our allocator available for us in the workspace, and I call it Ellie short. Is this by the way, is this a name? Looks like a girl's name, Ellie. Let's try to find Ellie Wikipedia, please. It's a company, novel, Disney. It's a character, at least. Let's look at Ellie. Okay, very cute, Ellie. Okay, Alice. Oh, it's a short for Alice here. Oh, no, it's a separate. She's a daughter of Alice. Okay, so maybe naming your daughter Ellie when you are Alice, not the best thing to do, but they did it, so who am I to judge, right? So it's a girl's name, we'll assume that. Oh, no assumptions, no assumptions. Let's try to do one more thing. We will need to do the allocation for this array first. And if I remember correctly, we should be able to do it here. And we can have a problem if we do it somehow. We can have a problem if we allocate something on the stack and then we try to reference it like here in this line. But now we don't really allocate anything on the stack because selection is like just numbers, just data. So let's try to do that. So we go try selection dot append. Is this append correct? Probably yes. Append Kisa dot selection, and we go with cursor and anchor, which are equal to just 0, right? This is an offset. Later on, we'll have here some variables. Let's put a to-do entry. Do add variables, customizing the position in the. So what it means is that we can have we can open a file already at the line 336 and column 10, something like that, and we would like to pass it in here in the init inside parents as a parameter. So here we create our selections, yes please, and we append primary selection here. Okay, we have it in display window. Now we should go to our text buffer and we should have a general framework for processing different requests about changing text buffer, which also give you a window ID. So effectively we would like to have some kind of proxy for all the requests to the text buffer, which will give window ID and more information how to actually change things. So let's think about a bit. One option is that we go to here. This is our implementation, just dumb implementation, contiguous array. And we go and put here like first parameter window ID, and then we query this window ID and we are fine. And I think it is not a very great approach, because here we would like to make a layer of abstraction which doesn't know about anything in this file at all. Like all this file, window ID, like panes, whatever, no idea what it is. So we would like to have an implementation that just knows about things it should control, things it should manage. So I think a better approach is a proxy method inside here. Maybe we will go and do it like so. Here it is, init, initialization, and display window. Probably go like so. Pub fn, and we say that we would like to have a command. Like so, probably. Command. Is this right? Okay. Why not? Why not? Oops, self. We go with, it says ID workspace ID, and here, yeah, probably we need just our state, and we need to understand which display window to query the request to. All right. We can do it a couple of ways. Probably just pass it here. Yeah. If we get a better idea of what exactly to do, we will do it. For now, we will just do it the simplest way possible. We can fail in this one, I believe. Or do we? I don't know. Let's remove it for now then. And first we go and find our display window. Display window equals probably var const. Probably const. It will be a reference to the display window. Oh, and we have a new follower, Daniel Diabin. Thank you for the follow. Thank you. I hope you are enjoying the stream. If you have any questions, feel free to ask. Okay, now we go and say self find. Alright, and now our display windows, so text buffer, and it has several views, several display windows, several ways to view it. For example, here is my current editor right here, right? And I can create another display window and open same file state. And it will be different, right? It will be different window, but I still have some cursor and stuff, and this is what I call display window. I use long names so they are understandable for everyone. And our display windows are represented as a doubly linked list. Here in Zig terms it's called tail queue. I have encountered this name for the first time, but I believe it is also a valid name for this data structure. But it is a doubly linked list, and as a matter of fact we can find out that there is no such window actually. And what do we do if there is no such window? Find display window, and we pass it self. Oh, we already passed it self. Display window ID. So it can be null. It definitely can be null. And if we find it, here it is, we can reference it further in the code. But what if we don't find it? So there are two options we would like to consider. First is we can error out. We can return an error. Return error display window not found, like so. Or we can just do nothing. I believe that, and there is another way that we can say, oh, it is not possible. We as human beings, very smart, extremely smart, we can understand every possible way the program, every possible path the program can take, and we can predict that it will never happen. I believe we, in theory, we can, but it looks still do not understand fully everything. So maybe we can here make an error. This is this means that catch any error that's going to be returned. This is like a Zig way of doing error handling. A lot nicer than Go, and I believe it is somewhat similar to Rust, but I think it is even better than Rust. And we can now just do error, and probably we will do some requests where we can find display window. Yeah, I think it is very possible. For example, yeah, I think I do not have enough information right now to answer, and I believe if I don't have enough information, we'll do the dumbest way possible. We say it can never happen. Unreachable. And we will leave an entry to do. Is it really unreachable? So later in the program, later in the development, we will understand and fix it if we will need to. Okay, now we are happy path. We have our display window, which is actually a display window node, I believe. And we would like to get our display window. Or do we? Probably, and actually not really. We just want to change the selection. And probably it means that our commands should partially return selections. At least some of them should return selections, because we need to change it in the display window. And we'll do something like that. Display window node data. Data is where the actual data is. This is allocated on the heap. And we go selections. And we also have... Alright. I thought that we will have to pick the exact selection we need to, but we probably can return just the whole array of selections, primary, secondary selections, right? And go like modified selections, like so. Yeah. And this is our final line. Let's write previous lines because we still need them. So command, we need to know which command, like which command. And for that, command type. We already use the word command. Let me check quickly, how do we use the word command in our code base? So we already have command request. I think it's probably fine. We probably mean same thing about command. Here commands. Okay, let me take a look at src main.zig 69. Yep. Main.zig 69. So this is our interface for the commands. For now it does error handling, you see it here, and it does communication with the client via RPC protocol. Here we send something back to the client. And what do we do here? We say new text buffer. Oh, okay. So now when I think of it, maybe this command should live in the state and have more power about what it is allowed to do. For now, we try to keep it very scoped around communication with the client and just receiving requests. So I don't know. So we will add a to-do entry. Everything is simple in my life. I just add a lot of to-do entries and just spend a lot of time offline thinking about these things. Because right now I would like to just hack something up, do a prototype, and be happy about ourselves, right? What do we do with the commands in the main.zig? Okay, for now we will assume that we are fine with that. We'll have command kind and enum with all the possible commands that we can have, and we will say that do we have like some kind cursor move down? What is it? Cursor move down is somewhere. Where is it? Let's take a look. We use grep for that. Config and command kind. Oh, we already have command kind. Oh, that is brilliant. I believe it is left from previous implementation where we had event dispatcher, which I just deleted. We will add it later, but not in the same way which I did it at the first. I realized that there are some design decisions that are not compatible with what I would like to do. Okay, so it is in src Kisa. It means it is globally available to us. So let's go to our state text buffer state. Yeah, here we already have command kind. Kisa dot command kind. Yeah. So now we do what? Do switch on command kind. So we would like to respond differently to different command kinds. And what do we want to do? We would like to dispatch on move cursor, move left. Let's do that first. Oops. Delete this. Else we will say just panic, not implemented. Implemented. Yeah, like so. And we go and add here our logic. So first we would like to find. Okay, we will do it a bit later. Now we would like to do what? We would like to have a command in our implementation. Probably would like to have a public function cursor move left. Okay, cursor move left self, and we would like to have selections. So it will be yeah, I think we will have to use selections a lot, so it is worth having it as a separate type. So selection here it is like so, and pub const selections with s will be std. Do we have std? Yeah, we have it here. Std array list selection. So we can just not do a lot of typing. Selections. And we go void. Probably we cannot fail it. I hope we will not be able to fail it at least. Everything is possible. Everything is in our hands. Okay, we go cursor move left. And we do some implementation here. For now we will do this, so Zig doesn't complain about unused variables or anything. We just say that, yeah, we do it like so, and yeah, we should return the selections. So we return the selections. And now we just say selections. Probably will say modified selections. Okay, this should compile. Now go here, we say that our modified selections is, since this file will be embedded here via pub using namespace, and using namespace, basically what it does, it takes all the methods here, and it inserts it like directly into this buffer. So it is directly available at the same level. For us it means that we have it like on the same level as we are here. So we say self.cursor move left. Where is cursor move down in main? I saw an auto-completion. Cursor move. Is this? Oh. Do we have cursor move left? Oh. So we have move down. Can we maybe change it here to move left? Is multiplier. Okay, let's forget about it for now. Right, we don't want to connect the whole stack because it will be a bit hard to test it all as well. We will just concentrate on the state. Yeah. By the way, for a simpler understanding of what we have, server architecture design. This is our design, and currently this is the whole stuff. and we are concentrated only on the state here. State of our editor, it is all isolated from other things. We don't know, the state doesn't know about anything. Some things here know about state. Here it is like this box, which is expanded below. And a lot of things know about state, but state is like it's boiling in its own juice, so to say. And we go here, cursor move left, which is function from our array buff implementation here. And we pass it selections. Selections. And probably we do it like this. We say, so here, node, data, selections. Here you go. So I think this is our interface. We get our commands, get our ID, we find display window, we switch on the command, we get our cursor move left. We call this function, which we already have because we have it embedded from here, and we pass it to the window ID, which means we just changed our state. And I think it is what we wanted to do. We wanted to change the state, we did it, we are fine. Okay, I think this implementation should end here in scope. Let's also don't have this function, I believe. Have it in other. We have it in other. Have it in workspace container, but not in the text buffer. In the workspace, right? Yeah, here in the workspace. But we need it in the text buffer too. It will be a bit different, but probably same. So I will just copy the existing implementation and tweak it to work for this one here. Okay. These are public. This is private. This is yes, probably fine. So we go and namespace things properly. Display window node. Yes, probably correct. Var display window. Self display windows first. Well, we don't have display windows, but we have display window IDs, and we iterate through our doubly linked list. Display window IDs, right? And we say that display window ID DWID, and here DWID ID ID. Yeah, so we go display window IDs, tell display window IDs first, right? Then we go into while loop, and this while loop with these pipes, it means that iterate until this is null. And this will be null eventually because we call next, unless it is a circular list, which will never ever finish going in circles, so will end somewhere. And we just try to find the correct display window ID. Here we say that, okay, if we have our ID, we return our display window ID. Yeah, it is probably not entirely correct. We probably want to do find display window on the workspace, because here we will just return an ID. So I just realized what we do here. We pass an ID. Okay, we say, okay, we have an ID. We go to our list of all IDs. We iterate through the list. We find the node with the correct ID, and we return this ID of the node, which we have just passed. So we basically can write it like so, or maybe even like so. Return ID and will be the same. Okay. Probably not what we want. When we say define display window, we probably want to reference the workspace. And since we are in the same file, we can use fn functions in the same file. If it were a separate file, we will have to add a pub keyword saying that it is a public interface. So I think our find display window, do we even need it as a function? Probably not. Okay. So here we the one little trick, self workspace. Voila! I think we fixed it. So we just rely on the workspace having this function. Okay. We have all the scaffolds, no implementation, we have just all the structure, so it is all handled properly. Go to our array buffer, and we probably want to add a test here to check that it works. And yeah, I think test should be not exactly here, but it should be in this general file, in the state file, because we probably want all the implementations to have the same interface and have same behavior, and we don't want to have implementation specific tests, at least right now I think so. So we'll put our test here. Yep. So now let's try to compile it. Sometimes, like not sometimes, often it is it is an adventure of its own. So we will say state. We would like to run the tests in state, and we will have a lot of errors right now. Just see it. And errors. Alright, our first candidate, 825. It says expected type display window found. Oh, I see. It did not expect that we are going to fail here. So I needed to add this how's it called, exclamation mark, which means this function can return an error. And now we need to handle this error everywhere where we call display window.init. Here, try. And since we do try here and try here, if this try fails, we would like to free the resources which are allocated here. Is this right? Because same here situation, and we don't do anything here to handle the failed resources. Let me think of it. So here we just create memory, and if we fail here, we will leak this memory, we will not free it. Yeah, I think it is correct. Yeah, let's free this memory. So we type error defer. Error defer in Zeek means that do this at the end of the scope. Currently our scope is this whole function. And do this if we ever fail in the future. Right? This try we can fail, so we say error defer here to free the allocated resources if we fail to initialize it. Say destroy, self-valid destroy display window. I believe it should be like so. And I noticed that we do same stuff here. Let's also destroy it here while we are at it. Okay, let's go and try and test it. Six tests leaked memory. Oh, I think I understand. Yeah. In our implementation, we had to allocate an array for display window, which is here. So here we do an array list and allocation, and we don't really free it. We have a dneed function, and if we diligently put it everywhere where we ought to do it, we should be fine if we do just that. Self selections dneed. We should free the memory that we have allocated. And if we have put it everywhere, this dneed function, where we did init, then we should be fine. Okay, one test failed. Handle failing conditions. Fail out of memory. Oh, right. We have one test which checks that when you do things and something fails, you gracefully handle the failure, meaning that you don't try like do some magic stuff and magically restart, but you free all the resources that he required. We have just a single test for that, and there is, let me show you, new window pane. Yeah, here it is, handle failing conditions, and this is 14. This is a counter at which allocation we are going to fail. And I just noticed we have a new follower, Ramos. Please correct me if I totally butchered your nickname. Ramos. Thank you for the follow. Here is our number of allocations, and 14 is the number we are going to fail. So I assume that we have just added one more allocation when we append it to the list. So one more allocation, we should be fine with 15. Let's try it. Yeah, we are fine. So let's do our commit here. We go here, here, probably fine here too. We say state add scaffolds for the text buffer implementation. So scaffolds are ready. We are finally ready to actually do the implementation, and I'm getting a bit tired already. We didn't we wanted to do this stuff, we didn't even do the first topic, and I am already a bit tired. Yeah, we will try to complete it. So let's do a test-driven development. I believe that for this exact case, this is going to be fine. Test state, and we say that like commands, this commands text buffer commands, text buffer cursor commands. Let's put several cursor commands in the future here. So here we go. Need with text. Okay, we are fine with that. We have our text buffer, and we probably would like to also have a display window, and I think we should do it via workspace interface here. Our workspace it does managing of resources, and I believe that we should have easier time dealing with that. Yeah, need default buffers, so it basically has everything we need to do, everything we need to have, and we should ask it to just create a text buffer, new text buffer, like here, probably. Maybe not. Maybe it's too big. Probably it's too big. We don't want to test the whole workspace stack in order to test just implementation of a text buff. No, I believe it's a bad approach. Let's do what this workspace does just manually. We'll need to create a display window and assign it. New window pane. Open text. Where is it? Here. Find. Where is my create? Here it is. Create display window. Should be fine with that. Yep. Let's go and see what we do here. So we have display window node, arrow defer destroy, probably just defer in this test. Then we go init, we put it in the linked list, we init, we say that display window ID counter, yeah, it is an ID that we assign to each window, we say that just one, and say cell display windows no. So I think this is what we want. We create a display window in the linked list. Is this correct? Oh, no. We still have to have it. We are going to reference workspace here to find our display window, and it means that we will need to have a working workspace. And let me think a bit. Do we really want to have the whole workspace dependency to test just this? Just this little thingy. So the solution to this problem, to decouple it a bit more, is to do it like so. Display window. Display window node. Like so. So this is another possibility, that we handle finding correct display window somewhere in the workspace, and so we probably want to have like we have in the main we have here commands, and we have like cursor move down, and with this approach we will probably have like in this workspace proxy function command public, which will do some stuff here, and it will just proxy it to text buffer, and like so, and then in the text buffer we will actually do our changing stuff. But now it feels like a lot of levels of abstraction. Do we really need to go this route? At the same time, it does decouple managing resources and changing the state of the text buffer, testing different implementations. I'm always afraid to make such decisions, because they have very large implications, and it is very easy to make a mistake now with overly complex architecture and then suffer for the rest of the development years further. Well, probably this is how we are going to do it. Probably yes. Well, we can change it later. I believe we don't have to put it in the workspace here just yet, but at the same time, since we don't currently use this interface by anything, we can just make it like so. Have it commented, and here we go display window node. We just delete several lines of code, and we already have our display window node, like so. Okay. Okay, I think that will do for us. So what we need to do is just pass it display window node. Okay, let's go. Command probably with an error. Probably not. Don't know. Let's not put it yet. And we go text buffer command display window node. That is correct. Display window. Maybe we should say it here too. Display window node, and we say that cursor move left. Oh, finally, we did it. So, what do we want to test right now? Right. We would like to get our selections first. We go here and say, oh no. Oh, right. Okay. Let's get our selections first. Selections. Display window node. Data selections. This is what we have at the very beginning. And let's try several certain assertions. Equal, yeah. We have our usize 0. Selections, the very first one. We have just single selection. Let's get a single selection. Or no. Oh, okay. In the very simple test, we will not think about anything like that. Just simplest, dumbest thing we can do. Selection, we test that cursor is at offset 0. And then we test that anchor is at 0. And we test that true, our cursor is indeed primary. Yep. And now when we move left, actually we shouldn't do anything here, because we are at the very start, at the very beginning of the buffer. We shouldn't do anything, so the selection should stay the same. Maybe we should do it like so. Yeah, and we go and do same stuff here, and we actually already have a passing test because nothing changed. So idea is that we get this selection from the display window, and since it is allocated on the heap, it is a reference, so we don't get a silly copy somehow. This command actually modifies the selection. We query it one more time and check that nothing changed, because we were at the very beginning. Let's check that tests pass. Yeah, okay, let's just do several stuff. Self alley will change it. Oops, I pressed the wrong button. Alley would like to change it to testing.allocator. Display window node. Sure. I will help you and say where it is. Display window init. Oh, we need a workspace here. But I guess we can leave. We can leave with just workspace, which can just create like an easy version, just with the allocator. Init alley. Yeah, we will do it like so. Workspace that init testing allocator. And just to be a good citizen, we will delete it in the defer, although we didn't have to do it. Expected, yeah, we should, this is a const workspace, so we mean that we don't want to change it anyhow, and it is also a constant reference, which says it here that it is a constant reference, and we expect just a reference. Let change this on. Yeah, and we just change it to var, so we pass a mutable reference. Array of access of non-array type. Sure. We should write dot items. This is how we do access on array lists and interface. No member named command. Instruct std array list. So why does it say that? Why does it say that it is std array list u8? It is like our implementation, probably. What's text buffer? Text buffer need contents with text. It's probably not correct, is it? We should use this in it. Okay. Yeah, it's fine. Nothing too worrisome. So we should just pass these params, because here you need with all this scary stuff is from the implementation. We go var text buffer equals try text buffer dot init, and we pass it an allocator, and as a second parameter we should pass it text buffer init params and a lot of init params. Let's just copy them from text buffer. Here they are. We should do it with a dot, and we should change all the columns to equal signs. So path, we should pass here null if we can. Contents, we can pass here hello. Name, let's name it text buffer name. Sure. And read-only, we can avoid passing this flag. So now it should be a proper text buffer. Expected type found. Right. It wanted me to pass not an allocator but a text buffer. So here you are. Okay. 8 to 9. Yeah, I think problem is that we would like to expect here a reference, not a copy of the data. And use undeclared identifier 777. Here it is. Yeah, we just should declare it. No problem. Selections. Sure, it is in text buffer array, and we go array selections, and we help it understand what selections we are talking about. Yeah, it should understand it now. In 52. Sure, we are fine with saying it is a const. 1 errors were logged, 1 test leaked memory. Okay, let's go and check out our test case. man, here it is like it is 30 lines just for move left. I want like 10,000 lines of tests for all the movements of cursor. Like it is a lot of code for just moving left, and it is just a corner case when we are at the very start. We should also have a case when we are not at the start. Okay, let's actually look at the output. Oh, it is even in another test. Stay at close window pane when there are several window panes. Okay, let's try to understand why did we fail. Yeah, it says something about selections append. Probably we failed to free the memory somewhere here. Yeah, we were not a good citizen. We did some allocations without de-allocations back then. Or rather, initialization without de-initialization. So now we should figure out where we did it. So there are some 8 to 0. 8 to 0. Zig is very helpful actually about all this stuff. It's unlike C, C++, where we get like, hey, scaffold. Here it actually says what's wrong and all this stuff. Okay, so we were okay. We just didn't write good tests. It's fine for the tests. Oh, all tests passed. Okay, so let's actually implement something a bit different. So here we have this case should be that one, but we also should have another case. We would like to understand that yes, it actually works, and we will implement just moving one cell to the left when we have our cursor and anchor at the same position. So Vigila says nice i3 bar. Yeah, thank you. I even did some work on it. Some icons, I believe, or I chose diligently my icons. Now they're pretty on the eye. I also had a plan to write my own implementation in Zig, but so far it's only a plan. As it is always in our software development. Okay, let's create maybe data selections items.0, and we say that hey, we actually have a selection, a particular kind of a selection where cursor is at position 1 and anchor at position 1 too. And now when we do move left, we want it to actually move left. So we do command one more time, and we want to have zeros here still. And now it should fail, because we didn't really implement it. Yeah, it failed. And let's go and implement it now. At least. What is it? 1 hour 45 minutes in, we are implementing move left, what we wanted to implement from the very start of the stream. Very productive, very productive. Okay, self. We will not do anything with self, as I understand it. So we will just put it like so, but we would like to do something with the selection, with our selections. Self here is just for the interface. But selections. Let's go and change selections. So we will do what? We will have modified selections. So we will perform a copy into modified selections, and then we will go through this copy and modify it, and then return it already modified. Okay, that sounds like a plan. So in Zik we can do it like so, with 4 if it is an array. And here is how we access it. Modified selections, items. Oh, actually, this selections is Kisa. This selections is actually an array list. So we should modify it in. We should modify it in place, I believe. I don't think that we are allowed to return it. I think we should pass it by reference here. Because here it is memory. This is going to have memory, right? And if we do a copy here, then we perform like a copy with link to the same heap memory, and it's not good. Not good. Very bad, actually. We can have subtle bugs in here. So what we're going to do is we're going to pass a reference to this array list and modify it in place. So first thing is here, we do it like so. And we don't return anything right now. And we go and change our call inside. So now we did it like so. Modify selection, blah blah blah. And we do it much easier. Since we modify it in place, we just pass it like so. This is a reference to the array of the dynamic data on the heap. This is a reference to the heap. And since it is so, we can modify it in place, and we are Gucci, as I said. So, for each selection that we are going to modify, we have two options, I believe. If it is at the very beginning, and if it is not at the very beginning. And, of course, also if it is anchored and if it is not anchored, right? Okay, let's say it like so. If selection dot cursor equals 0, which means its offset in the buffer is 0, then we do nothing. So how do we like so? Probably not. Probably we say if it is not 0, then we write some code. So if it is not 0, or if it is more than 0. No, if it is less than 0, then we will get an error at runtime because it is of type usize, unsigned. So it will be undefined behavior. So we probably shouldn't expect it to be less than 0. Let's get our undefined behavior in this function if we ever get it, because it will be a programming error and we would like to get it as soon as possible so we can fix it. And yeah, general idea is that we go like this, and we accidentally somehow get selection that cursor with a value, negative value, like -5 or like something like so. It is probably because of undefined behavior, and it will be probably not -5, probably minus 356,000, 600, and you get the idea. Just a random piece of memory. And if we check it like so, then it means that this function cursor move left is going to work as expected, but some other functions that rely on the cursor being always non-negative, they will not work correctly, and we probably want everything to break if we do something wrong. So break everything, crash as soon as possible. This is philosophy for this subtle moment. We go selection cursor not 0. We just say selection dot cursor -1. Okay. And now we check if selection dot anchored. So if it is anchored, we should not touch it, because cursor should move no matter how cursor moves, anchor should stay at the same place. But if it is not anchored, we should move cursor and anchor together. And do we check that anchor is also not 0? Now when I think of it, it is like an interesting case that we should check it if it is not 0 in the case like we have a selection and we would like to move the selection as a whole, like one cell left, like whole selection. I believe it is not implemented in any editor I know, and probably for a good reason, but we probably shouldn't make a hard block here. Well, it's not a hard block, but okay, if selection anchored, we don't do anything, but if it is not anchored, we also go anchor -1. And probably yes, probably we should check the anchored, that it is not 0 too, because if someone is going to implement something like that, like an extension, we probably should also check for that. And anchor. Okay. Moment of truth. Okay, let's just compile it. Yeah, self cursor 777. Yeah, you're totally correct. We should pass it by reference. I agree. Whoa, and everything passes. Beautiful. Just beautiful. You see? All these tests, we wrote them and it passes. Let's maybe commit this beautiful stuff. Probably make another to do, just to think a little bit. To do. Or maybe not. Maybe I thought about adding a to do to think whether we should put command in workspace as a function, as an interface to the state as a whole. So we go, let me show you on this schema. Yeah, from the client we receive our JSON RPC request, cursor move left. We receive it through transport to the server, and probably we receive a key, right? Like a key like H. We receive an H, it is left in Vim bindings. Server goes to the key map. Hey, here's the key H. What to do? Key map says, okay, man, I can handle that. It says H, according to my register, it is move left. It says commands move left. Now commands finds, commands does move left. Okay, I should do all the necessary stuff. It will mutate the state, and this one event dispatcher will do it later. Currently we don't have it, but it will do. It will command the state to move the cursor left, and in our idea we are going to say that workspace says cursor move left. It gets necessary window ID and all the stuff. it finds all the resources, because window ID is responsible for all the elements. Here it says is a collection of all the elements which can be considered as state, and it operates on them from a high level perspective. Probably we should say also that it manages resources of the state. I think it is a very concise and good documentation. Okay, workspace is responsible for managing the resources of all the parts of the state. Yeah, and since we would like to get a display window, we probably should ask workspace to get it for us. So we will have a function in here, command. It will find display window, and only then it will proxy it to the text buffer, and text buffer. It will proxy it here, and here in this command we will also dispatch it through our interface and call the function of the underlying implementation of our text buffer. Currently it is contiguous array, the dumbest implementation, just to understand the interface and all the stuff. Yeah, and this is what we have right now. So I believe it is very good start. So far I like the general interface. I like that we have solved the scaffolding. We have this is although we didn't do a lot of stuff, we still did scaffolding and all that, which requires some thinking, some design decisions. Right, I actually like to do this kind of stuff. There is one point when you do like things in here, implementation of the text buffer, where we'll have to do like a lot harder things than that. Like really harder things than that. Like this one, not consecutive lines. When we have some folding in the code, this will be like very difficult to implement, or at least it seems to me like so. It is like technical, like a geek, like a nerd stuff to implement that. It is one thing, but another thing is design, like general design decisions, where to put things, how to access things, how do you go about abstraction layers, isolation, and all this stuff. It is also another side of the coin of a programmer. On the first on one side you're a crazy geek which does all this algorithmic stuff, all this managing stuff, and doing crazy stuff with the fingers, right? And on the other side you're an architect, you're smart man, and you do all this thinking. Yeah. Okay, let's commit what we have now. Let's review it. So we added a comment, we modified this interface a bit, we wrote our test, and we wrote an implementation for cursor move left. So I believe it is looks good. Complete implementation of cursor move left. Okay, so I think at this point this is a good point to stop doing what I do and return later. I will try to do some things offline, maybe some less interesting things like moving cursor to the right. It's probably not too interesting, and I will try to come back with something really interesting, or not, who knows. Okay, so I would like to thank everyone who is watching, who was watching. We had several communications in the chat. Not a lot this time, but I still appreciate everyone who participates in the chat. Thank you. And we had several followers, and I have a very good mood at the end of it. I finally did it. Finally did some update and all the stuff. So Ravi says, can you share your experience of Zig programming? It's great, Ravi. It's great. Just try it. Just go here, ziglan.org, and try it. Try it. It's magnificent. I would really recommend it if you do some low-level stuff. If you are interested in memory management, memory handling, resource handling, if you want to go low level, I would recommend Zig. Beautiful choice. Show me its GitHub star. It has a lot of GitHub stars. I'm sure if you are motivated enough, you will find GitHub stars and a lot more. Try it and see it for yourself, Ravi. Okay, I believe it is good time to end the stream. I thank you all for being with me, for watching, and for all the future viewers on YouTube. You're also awesome. Thank you all. Bye.